In this video, we're going to have a look at the form of the hyperbola and all the transformations it can undergo. The standard equation for a hyperbola is a divided by x plus p plus q. In grade 10, we only focus on the transformations of a and q. To determine the form of the hyperbola, we are going to start off with the mother graph of y is equal to 1 over x and complete a table to get enough coordinates to plot to see the pattern. If I start by substituting x with minus 2, I will get a y value of minus a half. Next, I will get minus 1 and then minus 2. For the positive x values, we'll have 2, 1 and a half. If I substitute the x value with a 0, you will see that we get a value that is undefined. This means that there is no coordinate on this graph where the x value is 0. This means that this graph has no y-intercept, because normally the x value is 0 at the y-intercept. Similarly, if you want to determine the x-intercept by substituting y with 0, you will see that there's no x value that you can substitute here to get a value of 0, and that means there's also no x-intercept. This brings us to a new definition. An asymptote is a horizontal or vertical line that a graph approaches but never touches. Here we can see that the hyperbola will never touch the x or y axis. We now saw that the hyperbola has two asymptotes. Firstly, it can never touch the y-axis because the x value can never be 0. And similarly, it cannot touch the x-axis. If we now go and plot all the coordinates that we calculated, you will see that this graph consists of two parts. The first part, and then it has to jump over the y-axis and the x-axis to form the second part. If we now go and draw the hyperbola, it will look like this. So here you can see that the bigger the x value that you substitute into the denominator becomes, the smaller the y value becomes. It will move closer and closer to 0, but we now already know that it can never be equal to 0. Let's go and have a look at what the influence of the a value and the q value will be on the graph. At the moment, the a value is 1. If I now increase this value, you will see that the graph moves further and further away from the axes. This a value can also become negative. And just like with the parabola, a negative a value indicates that the graph will now be reflected around the x-axis. This means that the part of the graph that's above the x-axis will be reflected and now be below the x-axis, and the part that's below the x-axis will move to the top. So the negative a value will look like this. And the bigger this value becomes, the further away the graph moves from the axes. The next transformation is to add or subtract a q value. And just like with the straight line and the parabola, this constant value indicates a vertical translation. If I make this q value positive, the whole graph will move upwards. And if I make this value negative, the whole graph will move downwards. With this translation, it is also very important for you to take into account the two asymptotes. Firstly, the vertical asymptote on the y-axis or the line x equals 0. Because the graph is moving up and down, this asymptote stays as it is. But the horizontal asymptote on the x-axis or on the line y is equal to 0 has to move along with the graph. So when I have a positive q value, this asymptote also moves up along with the graph according to that specific q value. So the bigger the q value, the higher this asymptote moves up. And the same goes for a negative q value. This q value shows you that the asymptote moved down. With a straight line and the parabola, the constant value indicates the y-intercept, but the hyperbola does not intersect the y-axis. For the hyperbola, this constant value indicates the horizontal asymptote. We first talked about the axis of symmetry when we did the parabola. This is a line that you can draw in such a manner that when the function is folded on that line, the two parts fit exactly on each other, meaning that they are mirror images. The hyperbola has two axes of symmetry. Firstly, we can draw the line y is equal to x. When you fold the function on this line, you will see that the top part fits exactly on the bottom part. Next, we can go and draw the line y is equal to minus x. And here you'll see that the top half of the hyperbola fits perfectly on the bottom half, which is its mirror image. So, the hyperbola has two axes of symmetry. The important part to realize is that these two axes of symmetry will move with the graph if it is translated upwards or downwards. For example, if I move this graph up 1 unit, you will see that these are not the axes of symmetry anymore. They do not form the mirror images. Therefore, these two axes of symmetry should also move up 1 unit. So here we now have our two axes of symmetry at y is equal to x plus 1 because it moved up 1 unit along with the function, and y is equal to minus x plus 1. So you can remember that the axis of symmetry for a hyperbola will always be at y is equal to x plus q and y is equal to minus x plus q. So we've now seen that when the a value is positive or bigger than 0, the two parts of the hyperbola will be in the first and third quadrant. And if this a value is negative or smaller than 0, the sections will be in the second quadrant and in the fourth quadrant. And then a positive q value moves the graph upwards, while a negative q value moves the graph down. This q value also indicates the horizontal asymptotes, which will always be at y is equal to this q value. Remember that a hyperbola also has two asymptotes. The first one is at x is equal to 0, and the second one will be at y is equal to q.